Ladies and gentlemen, good day. This is James from AGHAMALAYAN, and today we're going to talk about how to solve this problem that involves the application of free fall in physics. So let's try to first analyze this problem. So let's read. An object is thrown vertically. It has an upward velocity of 33 meters per second when it reaches 1/4 of its maximum height above its launch point. What is the initial or launch speed of the object? So let's first draw the diagram for this one. So at this point, we don't know the velocity yet, so we are still looking for the initial velocity. Then at 1/4 of the when it reaches 1/4 of its maximum height, the velocity is 33 meters per second. And of course, when it reaches the maximum height, the velocity now is 0 meters per second. So what equation should we use here? So the only applicable equation that we can use for this problem is v squared equals v naught squared minus 2 times the gravity constant delta y. So we know that the final velocity is 0, so 0 squared will still be 0, and then at that point the speed is 33 meters per second, so I'm gonna put some square over there, minus 2 times 9.81 meters per second squared, and then a delta y. So our delta y in this case, since this is 1/4, this 1/4, and then this is 3/4. Okay, what we should put here is 3/4 delta y. Okay, so computing the rest, we will get 3/4 delta y equals 55.5 meters per second. And then our delta y now, we'll just label this as delta y max, subscript max, equals 55.5 divided by 0.75. This will give us 74 meters. Now it is time to compute for the initial velocity when it is thrown. So we will still use the same equation. So v squared equals v naught squared minus 2 times gravity times delta y. And then v will be 0. V naught will be is what we're looking for, right? So v naught squared minus 2 times 9.81 times what we solved earlier, that's 74 meters. Okay. And then isolating v naught in this case should result to the answer of 38 meters per second. Okay, thanks for watching. I hope you enjoy, and please subscribe to our channel for more videos. Thank you.